Hello and welcome to the GCSE Maths Paper 1 warm-up ready for the 2016 exams. So this warm-up is designed to be used with Maths Made Easy practice paper number 4. If you haven't got that or you're working from home on a different practice paper, that's fine. This will still talk through some of the really common questions that are going to show up in your exam. Now, just before we start, we'll talk through a couple of things to do with exam technique, and these are really important. It's vital that you don't underestimate the importance of being a little bit tactical in your exam. So things to be careful of are making sure that you read the question fully every single time. So many exams I've marked where somebody has misread something in the question, and I get that they know it, and from teaching them I understand that they know what's going on, but they've missed out on some really key marks because they haven't read the question carefully. Second one, try and figure out what the topic is. This is a really good one to try and do. A good example of this might be grouped frequency tables. So there's lots of things you can do with grouped frequency tables. You can estimate the mean, you can draw a frequency polygon, you can do histograms, cumulative frequencies, and they're all slightly different, obviously. But if you can figure out what the topic actually is, then that helps guide you towards doing the right sort of working out and ended up at the correct answer. Third thing, this might sound really obvious, but make sure that you have actually answered the question. And the things I'm thinking of here are those big 5 or 6 mark questions where Jane wants to put lawn feed on her garden, but the question actually says to you, she has £100, can she afford to do it? Now lots of people drop a really simple mark by doing some fabulous working out, but then don't say yes she can or no she can't. So always make sure that you've actually answered the question. Number 4, always check your work through carefully. Nothing annoys me more than seeing people with 30 minutes left in their exam, their head on their desk, thinking that they have finished. I can promise you at some point in this exam you will make a silly mistake. The key is reading back through, identifying it and fixing it so that it doesn't cost you 1, 2 or 3 marks. If you're in my class at school, you will know that at some points I've always pointed out something really silly that you've done. People have got 1 times 2 wrong, and that's cost them 4 or 5 marks, but as soon as they spot it, they correct it and that question's okay. So check your work through carefully. If you've got plenty of time left, then for some questions, almost have a second go at them and see what's going on there. You can use things like substitution to check your answers. There's lots of questions where you can actually check your answer fully and guarantee that you've got the full marks on it. Number 5, don't leave any questions blank. I don't care if you're top set, bottom set, or somewhere in the middle, you should be attempting all of these questions, even if you're picking up the first couple of marks out of 5 or out of 4. Good example for this is vectors. Now vectors usually is broken down into 1 mark and then 3 or 4 marks for your part B, and every single person should be getting that first mark, even if you're not too confident with the higher level vectors. And number 6, this one goes without saying, show all of your working out. Now this one kind of hits you a bit more in the calculator papers, because obviously you tap a load of stuff in, arrive at an answer. Some people are tempted to just put the answer, but show every step in your working out. Okay, let's get started then with question number 1. So this is a fairly common question, stem and leaf diagram, and what I would do with this one, a little bit of technique for you, is every time I put a number into my stem and leaf, I would just cross it off so that I don't double count any of them. Whatever you do, it's a really bad idea to start scribbling these things out, because if you do make a mistake and need to go back and draw this thing again, if you've got really heavy inclines on there, you're going to struggle to see the number that lives underneath. So let's start off with this one then. So I'm going to start by putting my stems in place, and I can see that I'm going to need 0, 1, 2 and 3, and nothing goes into the 4 points, so they're enough there. And then if I add in all of my leaves, remember that these need to be in numerical order, and hopefully you're all looking at this and thinking, why hasn't he drawn a key? This would be my top tip. Don't forget to include a key. That must be there, because that helps me tell the difference between that 8 being 0.8 or maybe just a normal 8. The key helps me to identify what that is, and it's also your 3rd mark in this question. Question number 2. So on questions like this, these are asking for lowest common multiple, and the easiest way of doing this one is to list out your multiples. So for the hot dogs, which come in packs of 6, I've just carried on for quite a bit of a way, and I'm going to do the same down here for the buns, which come in packs of 15, and hopefully you can see that the first time I get a match is at 90. Now sometimes there'll be a slight twist on this question. They may say something like everybody needs 2 hot dogs in buns, but just again make sure you read it very carefully and understand what's going on. Now a common wrong answer for this one would be to put 90 and 90 or 6 and 15, something like that. You're going to count along and you need the number of multiples. So for hot dogs, it's the 15th multiple, and for the buns it's the 6th multiple, so I'd need 15 packs and 6 packs respectively. Question 3. Greg wants to find out how many times people eat takeaways, and he uses this question in a survey. Now hopefully you've seen lots and lots of questions like this. You're always looking for 4 different things on this one. Does it have a time frame? Do your response boxes overlap? Do your response boxes cover every single option? And the very last one is, are your response boxes numerical? Are they very specific? So things that are wrong with this question: there's no time frame given, so we're talking takeaways in a week, a month, and there are overlapping response boxes. So if I had 3 takeaways in a, well, it doesn't say, does it? But if I had 3 takeaways, I won't know which box to tick because 3 appears in both of them. Now as a little bonus one, some of you may have spotted that there's no option for 0 takeaways as well. So actually there are 3 possible things wrong that you could have come up with here. And for the part B, design a more suitable question, well, just stick to the rules that we've already said. Make sure you've got a time frame. I would include at least 4 response boxes. You don't need to do too many, but 4 is a good number for this. Make sure you include all of the possible options, and the ones that you're likely to forget are 0 and your 5 plus, 6 plus, 7 plus, the one at the other end of your scale, and make sure that you have no overlaps. So my question looks like this, and I think that's pretty good. Question 4. So on a question like this, I see lots of people trying to do some really complicated multiplications and divisions, and I see some people just think, ugh, that looks horrible, and avoid it completely. This is really easy. If this comes up, we're talking easy marks in the bag. The rule is this though: you must round all of your numbers there to one significant figure. Not one decimal place, not a number that you think looks nice and easy, one significant figure every single time. So 1.83, if I round it, is going to become 2. And what I'm going to do is change that in my calculation. 3.12, if I round it to one significant figure, is going to become 3. And the last one is usually the trickiest one. 0.17, if I round it to one significant figure, the first significant figure I reach is the 1 after the decimal place, but the 7 that follows that tells that 1 to round up, so this becomes 0.2. Now 2 times 3 is pretty easy, that's 6, and if you don't fancy the look of 6 divided by 0.2, I can't blame you, that looks quite horrible. Some of you might sit there and think, oh, I know what the answer is, that's pretty easy, I can do that in my head. But there's a nice trick that we can use for this one. What we're going to do is, as long as I do the same to top and bottom, I keep the value of that fraction the same. So to get rid of that horrible looking 0.2, I'm going to multiply the top and the bottom by 10, which makes it 60 divided by 2. Now I know that's a nice easy sum for me to work out, which is 30. So my top tip for this one is, if you end up with a fraction, and this will apply to other subjects or other topic areas as well, if you end up with dividing by a fraction and you don't know what it is, you're not 100% sure, then multiply the top and the bottom by 10, and you can make this a lot easier for yourself. Question number 5. These are quite common questions. They tend to come up in the Edexcel series quite frequently. They'll give you a list of ingredients and say that they make 10 cookies or cakes or whatever it might be, and you need to scale it up so that it gets to another number. Now it won't ever be the case that you can just times this by 2, 3, 4. So in question number 5, they would never ask you to work out 20 cookies or 30, 40, etc. There's always going to have to be a tweak you make at the start. So I always remember it like this: I'm going to have to divide and then times up. These questions will always get you to divide first and times up. So if I know that 10 banana cookies is made using 80 grams of flour, 12 grams of butter, 3 grams sugar and 4 bananas, and I need to get to 25, well, first of all I'm going to think about the factors of 10. So I've got 1, 2, 5 and 10, and of those numbers 25 is in the 5 times table. So 5 is going to be my stepping stone to get to 25. So let's start off with writing out the ingredients for 10, and to get to 5 cookies I'm going to divide all of those ingredients by 2. and that gives me 46, 1.5 and 2. Once I've got to 5, I now need to scale it up to 25. So to do that, I'm going to times by 5 and I get my new list of ingredients. Question number 6. This is a form and solve question, again really popular on the Edexcel series. The most common mistake you see on these ones is not telling the difference between the perimeter questions and the angle questions. And again, this goes back to exam technique of reading the question very, very carefully. So I can see at the minute that this is a triangle and I have 3 angles labelled inside it. So what I'm going to do is think about all my angle facts to do with triangles, and I know that the 3 angles add up to 180. So I'm going to take this 4x and I'm going to take this angle 2x plus 50 and this angle 4x plus 20, and as I said, those 3 angles are going to add up to give me 180. Once I've formed this, I'm going to simplify the left hand side to get 10x plus 70 equals 180, and then from here on in it's just a very simple straightforward solving equation to get x equals 11. Now these generally are worth 3 or 4 marks, but again, as I said, please be very careful. Make sure that you are 100% certain whether you're doing a perimeter or an angles question. I see lots of perimeter questions that are answered wrong because people have made it equal to 180. Question 7. Kaiser is a wedding planner. He charges a commission of 10% on everything that is bought through him for the big day, and so far he has bought the following things: a bride's dress, venue and catering. Kaiser earns commission on the 3 items and then a bonus of £50 from the happy couple. How much does he earn for planning the wedding? So this is a bit wordy and you need to kind of get to grips with what's going on here. First of all, Kaiser is the wedding planner, so he buys the things and his cut is 10% on top of that price. So if we work out the 10% of all of the costs so far, I can see that for the bride's dress he makes £75, and for the venue he makes £350, and for the catering he makes £175. Now if you total all of those up, that's £600, but you have to be careful because there's another little tweak to this question. He gets a bonus of £50 from the happy couple, which I'm going to add on at the very end. So his total pay for this is £650. Question 8. Really common questions again, expand and simplify. In your exam somewhere there will be a page of expand, simplify, solve, factorise, all of those kinds of bits of algebra. They tend to like to put them all on one page. So we'll have a go at this one then. If you expand out the first set of brackets, 5 times 2a is 10a and 5 times negative 2 gives you the minus 10. On to b, 6 times x is 6x minus 2 times 6, which is 12, plus 3 times x, which is 3x, and 3 times minus 3, which is 9. And finally simplify all of that to get 9x minus 21. Part C is where we're expanding a quadratic equation. I would always recommend using the grid method for this because it's very easy to slip on a sign or something go wrong if you're just using the arrows method. So if you're going to use a grid method, you would end up with x squared minus 9x plus 20. Part D, factorise this one. Again, if you use the grid method, this kind of helps you a little bit to work backwards, but when this one is factorised, you end up with x plus 5, x minus 3. And the solve, if you notice, follows on from that. So always worth checking the question before to see if it links in with what you're currently doing. And if I know that in factorised form x plus 5, x minus 3 equals 0, then that means I have 2 solutions, x equals negative 5 and x equals 3. Question number 9. So this is your fairly typical scatter graphs question, and it starts off by asking me to plot 2 points for 2 students who are currently not on the graph. So there are 2 students here, one who got 70 in maths and 85 in science, which isn't bad, and another one who didn't do quite as well. He got 20 in maths and 15 in science. So if I just put these on the graph where they should go, a couple of things to be careful of. Just make sure that your accuracy is really spot on here and you don't get your 2 axes mixed up. It links back to that exam technique of read the question very carefully. In part B, use your scatter graph to estimate the science score of a student who scores 60 in maths. I see lots of people attempt this question without a line of best fit. 99 times out of 100 they go wrong on the accuracy. So the first thing I want to see is a line of best fit. The other thing you need to show me or show the examiner is the lines that you use to do this estimation. So I can see that somebody got 60 in maths, so I'm going to go from my maths axes, which in this case is the y-axis, and read across at 60. I'm going to hit my line of best fit, spin 90 degrees and go down, and that will give me an associated score for science. And I can see that my line reads down at about 61, 62. So I've gone with 61. Now, when you've got this in front of you, it will obviously be easier to be a lot more accurate than I've been on the computer screen. You will always get a slight tolerance either way, but be as accurate as you possibly can. Part C, describe the relationship between maths and science scores. Well, I can see that there's positive correlation, which means that a high maths score corresponds to a high science score, and as one is higher, the other one is higher as well. So my top tip for this one is always to make sure you draw a line of best fit for the accuracy when you're estimating one of the variables. Remember, your line of best fit is not a line that goes through the most points. It's the line that best fits the trend of your data. Question number 10. So here are two shapes, both are regular polygons, that's important, and we need to calculate the angle marked X. So I've got two shapes here, a regular pentagon and a regular octagon. And the first thing I'm going to need to work out is what is the exterior angle of the pentagon. Now I'm not going to use the exterior angle, and the reason why is because sometimes they can give you more than two shapes joined together, and if you do an exterior angle for that, it will not work. So I'm a big fan of having one method that works as much of the time as you possibly can. So I always use the interior angles for this. Now to get the interior angles, first I'm going to work out the exterior angles, but I'm not going to use them as part of answering this question. So to find the exterior angle of a pentagon, I'm going to need to do 360 divided by 5, which is 72. And to work out the exterior angle of any regular shape, it's always that calculation, but you divide by the number of sides that it has. So if I know that the exterior angle is 72, I know that interior plus exterior adds up to 180, so it's a simple calculation to work out that the interior angle of the pentagon is 108 degrees. Now I'm going to repeat that process for the octagon. So to find the exterior angle of the octagon, it's going to be 360 divided by 8, which is 45, and then to find the interior angle, I'm just going to take that away from 180, and the interior angle here is 135. Once I've got those two interior angles, I know that the angles around a point add up to 360. So from there, it's a fairly simple calculation to work out that X is 117. Question 11. Now obviously there's 4 different types of transformations, and in this exam paper there's only one that I can focus on. You will get transformations in your exam, I would bet my house on it. It will either be translation, rotation, reflection or enlargement. You may even possibly get more than one. Sometimes on a higher tier paper, enlargement will show up in its grade B variety, where it asks you to use a negative or a fractional scale factor. So with this one, I can see that shape A to B has been a movement, and movement I know is called translation, and when I describe a translation I need to give a vector which talks about how much this shape has moved, and it's been translated by the vector 6 minus 4. A couple of things about vectors. Notice how mine is in a column and it has no line in between them. Sometimes I've seen people write these as coordinates, which is just your normal everyday kind of brackets. And sometimes I've seen a line above the -4 and below the 6 to kind of turn this into a strange vector fraction hybrid. Draw your vectors like this and you'll be absolutely fine. Okay, so as I said, this is just one of the different types of transformations you can come across in your exam. So my top tip here is to just have a look at the other 4. For a translation you need to say 2 things. First thing is you need to tell me it's a translation and then give me the vector. For a rotation it's 3 things. You need to tell me it's a rotation, you need to tell me a center of rotation, and you need to give me an angle and a direction. For a reflection you need to say 2 things. The first thing, tell me it's a reflection, and the second thing is to tell me where that mirror line is. And for an enlargement, again you need to say 3 things for this one. Tell me it's enlargement, tell me where the center of enlargement is, and what the scale factor is. Question 12. So this is a cumulative frequency graph, very common question that comes up, and we're going to need to add in some cumulative frequency totals for the weights of these lions. So I've added in my cumulative frequency column, and I'm just adding up all of the frequencies, and I should expect that they end up at 100. A nice little check that you can do at this point is to just read back through your question, because usually it will say it's for 100 lions or 50 teacups, whatever it might be, and make sure that that number matches, which mine does, which is good. Okay, next thing we're going to do is plot all of these points. Key thing to remember here is that you must plot your points at the upper end of your class interval. So you're plotting 8 against 50 and 23 against 100. So if I put all my points in, it will make a nice sort of stretched out S shape, which is what I've come to expect from cumulative frequency, and I join those up with a nice smooth curve. Notice that my curve does go all the way down to the x-axis, and it starts from 0, 0. It won't always start from 0, but it will start from the lower limit of your first class interval. Now in my example, and in lots of examples, that's 0, but just make sure that this joins all the way down to your x-axis. Now I'm going to use my cumulative frequency graph to estimate the median weight of a lion. So because I know that there are 100 lions in this survey, I need halfway in that, which is at 50. So I'm going to read from my graph at half of my cumulative frequency, which is 50. And if I read all the way across and down, and then I'm just going to mark on that that's median so I don't get confused, because I'm going to draw some more lines on this in a second. If I read across from 50, hit my cumulative frequency curve, spin 90 degrees and read down, I can see that my estimated median is about 155 kilograms. Now in the exam there's obviously a little bit of wriggle room on this, so you need to make sure you're as accurate as possible to hit within their tolerances. Part C. We're going to use the cumulative frequency graph to estimate the interquartile range. So to do this I'm going to need the upper and lower quartiles. So if I just work out that I'm going to read these from 1/4 and 3/4 of my total data, which is quite nice. This one is 25 and 75. So I'm going to stick 2 lines across just like I did with the median, and I like to label these because I've got lots of lines going on now, and if I need to go back through and change something or to check something, it's really clear to me where my upper quartile is, my median, lower quartile. So I can see that if I read these 2 off, they're going to read off at 195 and 107, and for the interquartile range I need the difference between them, which is 88 kilograms. Okay, part D. A lion is classed as obese if it is over 230 kilograms. Use your cumulative frequency graph to estimate how many obese lions are on the reserve. So to do this, I'm going to do the same kind of technique, but I'm going to switch around which axes I start from. This time the piece of information I've got relates to the actual data, 230 kilograms, so I want the weight axis, and I'm going to read up and then across to my cumulative frequency axis, so the opposite way which I just did it. So I'm going to read from the graph at 230, and if I draw a line going up, again it's labelled, I can see that going all the way across, this hits my graph at about 88. Now you've got to be really careful with questions like this, because there's one of 2 ways they can ask this. They can either ask how many lions were under 230, in which case your answer is 88, the number you read off at, because that's all of the frequency below the line. Or they might ask if it's over 230, in which case they do ask that it's over. So I need the difference between where my line hits the axes and the very top of this data. So there's 100 data items, I've read off at 88, so I can tell that there are 12 lions that are over 230 kilograms and fat lions. Question 13. Standard form, pretty standard, I guess, this question. Comes up in lots of different exams, usually on a non-calculator paper. You can always check your answers to these by counting decimal place jumps. So 0.000241 in standard form is very simple, 2.41 times 10 to the minus 4. Just be careful, remember that because this has become a small number, that power is a negative 1. And 2.3 times 10 to the 5 is an ordinary number, is 230,000. Now the next bit to this, first of all I'm going to need to work out what 5 times 10 to the 3 times 9 times 10 to the 5 is going to be. I completely ignore the bottom of this for the time being, and I know that 9 times 5 is 45, and 10 to the 3 times 10 to the 5 is 10 to the 8. Now I'm not just going to leave my answer there, obviously I need to deal with the divide bit, so 45 divided by 3 is 15 and 10 to the 8 divided by 10 to the 6 is 10 to the power 2. And that's all well and good, but the problem is that currently my answer is not in standard form. Remember, the number that's at the front cannot be greater than 10, and it can't be 10 itself. So I'm going to need to turn this into standard form. Now the way I like to think about this is I'm going to turn the 15 into a 1.5 by making it 10 times smaller, and to counteract that and to balance it out on the other side, I'm going to need my powers of 10 to become 10 times bigger. So the 15 becomes 1.5, 10 times smaller, and the 10 squared becomes 10 to the 3, 10 times bigger, and those two changes balance each other out. So my top tip for this one is you can always count the number of places your decimal point has jumped, and I'm being a little bit loose there with the mathematical explanation, but you can always check this just by drawing little bumps, if you like, between the digits, and always check that your answer is in standard form at the end. If you just left it as 15 times 10 to the power 2, you would not pick up full marks for this. Question 14. This question is all to do with indices. So in the first one, pretty simple, I'm going to deal with my numbers, then with my a's, then with my b's. So 2 times 5 is 10, a to the 2 times a to the 2 is a to the 4, and b to the 3 times b to the 5 gives me b to the 8. In part B, same again, deal with the numbers, then the a's, then the b's. 12 divided by 4 is 3. A to the 7 divided by a cubed, or a to the 3 is a to the power of 4. And b to the power of 3, well, it's not got any b's there to be divided by, so that guy's just left on his own and stays as b to the power of 3. Part C, this is one that people tend to get wrong. Remember that cube that's on the outside of the bracket happens to every single thing inside there. So the 2 is going to get cubed, the x squared is going to get cubed, the y to the power 5 is going to get cubed, and it's important that you remember how that cube affects the powers inside the bracket. So 2 cubed is 8, that's pretty nice and easy, and x squared to the power of 3, I multiply those powers together, which becomes x to the power of 6, and the same with the y's, giving me a to x to the power 6, y to the power of 15. The last one is a combination of two different higher level indices that are actually happening on this. A nice way of remembering it is if you actually physically say the power, so this one is negative a half, it tells you the two distinct things you're going to have to do. If you do a number to the power of a half, then it takes the square root. Any fractional power is a root, so if it was a third, it would be cube root. If it was 1 over 4, if it was a quarter, it would be the fourth root. This one is 1 over 2, so it's nice, bog standard, everyday square root. The other bit we've got to deal with is the negative, and whenever you've got a negative power, it becomes a reciprocal, which usually, 9 times out of 10, is nice and easy. We just make it 1 over. So this one's going to become 1 over 16 to the power of a half, and 16 to the power of a half is 4 because it's the square root of 16. Question 15. So on this one, to do this one, first of all, I'm going to need a table of values. Now sometimes they give you this in the exam, and sometimes they're a bit mean and don't, but important that you remember you will need a table of values to be going on with this. And then what you're going to do is substitute in all of these values of x into the equation they give you. In this case, it's y equals 6 minus x, to get your associated values of y. And you should always be able to see some sort of pattern here. If it's a linear equation, then you expect it to go up or down by the same amount each time, and if it's a quadratic equation, it wouldn't go up or down by the same amount each time, but you should still be able to see some pattern in terms of symmetry going on here. Once I've got that, I plot all of my points, and you would expect these to make the shape of a straight line. Don't forget to join them up and make that straight line. Now my top tip for this one is when you're doing your table of values, always start with easy numbers. Lots of people tend to start with -2 in this really complicated equation and then go wrong. But if you start with the easy ones like 0, 1, 2, you can build up a sense of what the pattern is in this table, and that can actually help you with filling out the rest of it and eliminating any mistakes. Question 16. So this is a grade B enlargement because we have a negative scale factor. So let's have a look at how we're going to do this one. First of all, I'm going to pop in my centre of enlargement, And once I've got this, I'm going to need a couple of ray lines. Now I've only drawn two. I obviously could have drawn more if I needed to, but I'm just going to draw the two that will define the outer edges of my shape. Now there's lots of different ways of doing this. My favourite one is to take a point on shape A and count how many up and down movements and left and right movements it takes to get to the centre of enlargement. And then what we're going to do is take those and multiply them by -2, which is going to make them twice as big and reverse the direction. So if I just take the first point, and the point I'm looking at the minute is the point that's on the left hand side bottom of the L shape, which I can see that to get from the centre of enlargement to that point is 1 to the right and 1 up. Now if I take that direction and double it but also flip it, I'm going to go, instead of 1 to the right, I'm going to go 2 to the left, and instead of 1 up, I'm going to go 2 down. So doubled and flipped. And I take all of my points and plot them and then join up, and my shape should look like that. Remember, because it's a scale factor -2, it's going to be twice as big, and every single length in this shape needs to be twice as big, and the negative is going to mean that it's flipped upside down. Question 17. Simultaneous equations. This should be meat and drink question. We should be picking up all of the marks on this every single time. So decide which of your variables you want to match up. It doesn't matter whether you match up the x's or the y's. In this case, I'm going to choose to match up the x's. So I'd like to put a little box around them so I don't forget halfway through, and this will help me with something I do a bit later on as well. Now to get these as matching coefficients, I'm going to need to times the top equation by 4 and the bottom equation by 5. So what I'm going to do is write these out again once I've successfully multiplied them by 4 and 5 respectively. Now the decision I need to make next is a really important one. I need to decide whether I add or subtract these two equations from one another. Now I was matching up the x's, so in my new rewritten equations I've got 20x and 20x, and I look at the signs of both of those. In this case they're both positive, and the only way to get rid of them or to eliminate them is to subtract from one another. If the signs match, you subtract. If the signs are different, you add, but it's only ever on the variable that you have matched up. So for example, a common mistake on this one might be somebody saying, well, your signs are different because you've got a positive and a minus. You've got plus 16y and minus 15y, but not interested in them at all. My signs are the same on the things that I've matched up. So I matched up 20x and 20x. They're both positive. The signs are the same. I subtract these equations. There's a few little tricks you can do to try and make this a bit easier for yourself, but as long as you're careful with your negative numbers, from here on in it's easy. So 20x take away 20x, that eliminates and disappears completely. 16y take away negative 15y is 31y, and 4 minus negative 120 is 124. Once I've got this, because I'm an expert in my 31 times table, I know that y equals 4, and it's really important that we don't forget to substitute back in at this point. So far I've only got 2 of these 4 marks, and I've got my pick of 4 equations here to substitute into. I'm going to pick the very first one, 5x plus 4y equals 1, because it's got relatively small numbers and it's got no negatives in it. So if I substitute in 5x plus 4y equals 1, given that I know that y is 4, that's going to look like this. So 5x plus 16 equals 1, subtract the 16 from both sides, divide both sides by 5, and x equals negative 3. Now this is one of those nice questions where you can actually check your answer and gain a bit of confidence in your exam knowing that you've got these 4 marks in the bag. All I'm going to do is take my value of y and x, 4 and negative 3, substitute them back into both equations. In the top equation you should get 1, and in the bottom equation you should get negative 24. So my top tips for this one: don't forget to substitute back in to find the other variable. Once you've worked out what y is, you're only halfway there. And if the worst case scenario does happen and you get stuck matching up one of these variables, okay, that's fine. If I'd have got into trouble matching up my x's, then what I would have done was maybe abandoned that attempt, put a line through it so it's still visible to the examiner, and had a go at matching up the y's. Because sometimes that can be a little bit easier for us. But don't forget, if you do get into trouble with one of them, you've always got the option of saying, okay, I'll try this again, but this time match up a different variable. Question 18. So I need to say all of the values which fit the inequality given, and I can see that n can be anything greater than negative 3, and it can actually be negative 3, all the way up to and including 2. So I just make sure I write all these out very carefully. If I'm representing this inequality on the number line, first thing I'm going to do is pop a circle on 4, because that's on the left hand side of my inequality, and because this is greater than or equal to, I make that a filled in circle. Down at the other end, I'm going to pop a circle on 1, but this time that's not going to be filled in because of the inequality. It's not equal to 1, and I just need to join these two up with a nice straight line. To solve this inequality below, this is very similar to solving an equation, but whatever you do, you must not put an equal sign. This is an inequality. If you drop an equal sign in there, and it's easy to do because it becomes habit to write 4x plus 3 equals this and 5x equals this. It's very easy to do, but remember, you must keep that inequality sign constant all the way through. So if I expand my bracket on this one, keeping the inequality sign there, subtract the 12, again, keep an eye on the inequality sign, and x is greater than or equal to 3. Question 19. So we're rationalising the denominator of 4 over 2 root 5. Now to do this, I'm going to times it by 1, which might sound a bit weird, but bear with me. If I times that fraction by 1, then it stays exactly the same. It doesn't change its value. But the one that I times it by, I can make look a little bit different. So for example, I'm going to use the fraction root 5 over root 5. Hopefully you know that any fraction with the numerator and the denominator matching is the value 1. So what I've times it by there is 1, but I've written my 1 in a slightly clever way. And the reason why I've chosen this one is because I have a root 5 on the denominator of the question, surd, that it's given me. So I'm going to times these two together. So on the top I'm going to have 4 times root 5, which is 4 root 5, and 2 root 5 times root 5. The root 5 times root 5 will come together to become just 5, and it will leave me with this. I tidy up the bottom. 2 times 5 is 10, and always be looking to make sure that you have simplified fully. So I've spotted 4 over 10, which I know is the same as 2 over 5. So my final answer for this, fully simplified, is 2 root 5 over 5. For part B, I'm going to use my trusty grid method for this one. And I set it up with my first bracket on top, my second bracket down the side. It doesn't matter which way around these are. I like to do the grid method for this one because it helps me to eliminate any possible mistakes I might make. It's easy to do because surds are an AA star topic, and I've got different signs floating around in there. It's just a little bit more thought required. So if I've got it laid out nice and clear in front of me, it minimises my chances of making a mistake. So we're going to start off then. 3 times 5 is 15. And then 5 times root 2 is 5 root 2. 3 times negative 3 root 2 is going to give me negative 9 root 2's. And root 2 times negative 3 root 2 is going to give me negative 6. Now if you're not sure where the negative 6 came from, I've got a positive times a negative, so that's why it's a negative answer. Root 2 times root 2 is 2, but that's also being times by the 3. So 2 times 3 gives me the 6, and remember we said that it was going to be negative. So once I've got all of these terms, I need to make sure that my answer looks like the form that they've given me, which is a plus b root 2. So the 15 take away 6 is going to combine, and the 5 root 2 take away 9 root 2 is going to combine. So my final answer for this one is 9 minus 4 root 2. Sometimes the exam question will play a bit of a trick on you and say, can you tell me what a equals and what b equals? That's absolutely fine. In this case, a would be 9 and b would not be 4, it would be negative 4. You'd have to state the sign as well. Question 20. We're on to algebraic fractions now. So simplify fully 2x squared plus 3x plus 1 over x squared minus 3x minus 4. Now these are actually a lot easier than you're probably thinking that they are. All you need to remember is when you see something like this, factorise both expressions. You're expecting at some point something to cancel. So let's have a look at this one then. I'm going to stick in a line, and I need to factorise the top line, and then I'm going to factorise the bottom line. So if I factorise the top line, I'm going to end up with 2x plus 1, x plus 1. If I'm not 100% sure that that's correct, I can expand the thing back out and double check that it gets me back to 2x squared plus 3x plus 1. And then if I factorise the bottom, I'm going to have x minus 4, x plus 1, and hopefully you can see that those two will cancel, and that means that when I simplify fully, it's 2x plus 1 over x minus 4. A couple of tips on this one. The numerator of this algebraic fraction looks nasty because of the 2 in front of the x squared. So my tip here would be to start off by factorising the bottom one. Factorising x squared minus 3x minus 4 is much easier. And once you've got this factorised as x minus 4 and x plus 1, you know that one of your brackets on the top line is going to be the same as those. So it kind of gives you a bit of a hint and a bit of a way into unlocking and factorising the top quadratic. But just take your time with these. Remember that you can check your answer as you go through. If you're not sure with the factorisation, expand it back out, check you get back to where you started from. Question 21, everybody's favourite question, this one, vectors. Now, always make sure you at least get the very first mark on this question because it's an absolute gimme. So we need to write down an expression for the vector that takes me from point D to point B. So locate those on your diagram, D and B, and you can only travel along the lines that are given to you, and you only want to travel along the lines that you have information about. So the journey I'm going to take, I'm going to go from D to A, which is minus 6B, and it's minus because I've reversed the direction. I can see the direction because of the way that the arrows point. So minus 6B plus 2A. So as easy as that. And all I've done when I've wrote my answer is I like to start with a positive term, so I've gone 2A minus 6B. Now the next one is a really common question when it comes to vectors. Prove that xyc or yxc is on a straight line. Now to do this I need to show a couple of things. I need to show the vector that gets me from y to c and the vector that gets me from y to x. And what I'm looking for this is I'm looking to prove that they are multiples of each other and they start from the same point, because if they do that then they must lie on the same straight line. Now there's always an easy mark you can pick up here as well, as long as you remember that if you're going to show yxc is on a straight line, as long as you remember that you need to tell me what yx is and yc, one of these two is easy. And the easier one here, can you spot it? The easy one here is y to c. If I'm going from y to c, I'm going to go minus 4b plus 4a. Easy as that. And again, just like before, I've switched these around so that I have a positive term at the front and called it 4a minus 4b. And that will take me from point y to point c. From y to x is a little bit trickier. And the way I'm going to do this is I'm going to go from y to d, and then I'm going to want half of d to b. Now the reason why I've chosen that way to go round is because if you look in part A, I've already worked out what d to b is, and part A will always give you a clue as to part B on a vectors question. So from y to d, well that's pretty easy, that's just 2b, and then I'm going to want half of what db is. Now db I've already worked out, as I said that's in part A, so that's where your 2a minus 6b has come from. Once you've got it in this phase, you need to be very, very careful with your algebraic skills, because all I'm going to do now is expand that bracket the same as if it was x's and y's and it was question number 6 on my exam, just expand a bracket. So the 2b is going to remain, and a half times 2a is just an a, and a half times negative 6b is minus 3b. So now I've got a nice piece of algebra with b's and a's. You'll notice that the b's will combine. So to get from y to x is just the vector a minus b. Now I'm going to go back over to the other one. From y to c we said was 4a minus 4b. And actually going back to that idea of thinking of this in an algebraic sense, I could factorise a 4 outside of this. So if I did that, I end up with 4 bracket a minus b. Hopefully from this you can see that yx is the vector a minus b, and yc is 4 times bigger than that same vector. So what I've proved is they start from the same point and they are multiples of each other. And I just need to write down a sentence that states that. So yc is a multiple of yx, they both start from the point y, so they must lie on a straight line. And remember that yc is 4 times bigger than yx. Question 22. So hopefully you are recognising this as a tree diagram question. If you get a probability question towards the end of your paper, calculator or non-calculator, it is going to be a tree diagram problem. So I go up to the fridge and there are 3 different types of sandwich I can take. I can take egg sandwiches, ham sandwiches or beef sandwiches. And Matthew's going on a hike and he's going to take 2 sandwiches at random for his lunch. So the first thing is him putting his hand in the fridge, and he has a selection of 3 things that can happen. He could get egg, ham or beef. So that's how I start to structure my tree diagram. When you do these things as well, just take care. Take a bit of time on these to make them as neat as possible. That's not just me talking about presentation for your books looking fantastic and wonderful, but it's important that you get these things laid out correctly so that you're not ended up with really scrunched up writing trying to figure out what's going on in this. Make it very, very clear, easy to read for your benefit. So what I'm going to do now is pop on the probabilities that he picks egg, ham and beef. So there are in total 9 sandwiches in the fridge and 2 of them are egg, so the probability is 2/9. 4 of them are ham, probability is 4/9, and 3 of them are beef, so 3/9 for that one. Now this is where things start to get a little bit trickier. Once I've taken the first sandwich, that goes in my bag. It does not go back in the fridge. So there are no longer 9 sandwiches in the fridge. There are now 8, and that needs to be reflected in my second choice. So once I've picked my first sandwich, there are still 3 options that I can take, but I'm going to need to put in the probabilities. If I took an egg sandwich first, there were 2 egg, 9 in total. If I take an egg sandwich first, then that means my next round of probabilities, there'll only be 1 egg sandwich, and there'll only be 8 sandwiches in the fridge. So the probability of a second egg is 1/8. There are still 4 ham and there are still 3 beef, so it's 4/8 and 3/8 for those ones. In the second round, this time it assumes that I took ham first. While the number of egg and beef isn't going to change, that's still going to be 2 and 3. There's only going to be 8 sandwiches in there, but instead of 4 ham sandwiches, there's now going to be 3. And that's reflected in my probability change into 3/8. Third thing that could have happened is I took a beef sandwich the first time round. Again, this is going to take it from 9 sandwiches down to 8 sandwiches, and it's not going to change the egg and the ham, but the number of beef sandwiches reduces by 1, so that becomes 2/8. Once I've got my tree diagram in place, I need to sum all of what's going on the different branches. So the first branch, in summary, is the probability of egg and egg, and I multiply those 2 probabilities together. Remember, when you multiply fractions together, you times the numerators, you times the denominators. Now notice that I'm not simplifying this to 1/36, and there's a reason why. I'll come to that shortly. So if I just fill in all of the various different probabilities for my different options, so I've picked out all of these things: beef and egg, beef and ham, and beef and beef. Now there's a couple of things I want to draw your attention to first before I even answer this question. If you take the first 3 options that I had when I opened the fridge, I've got 2/9, 4/9 and 3/9. You'll notice that they all add up to 1, which is a pretty important number in probability because all probabilities of your outcomes are going to add up to 1. If I chose an egg sandwich first, and then I've got my 3 new options, egg, ham and beef, with probabilities 1/8, 4/8 and 3/8, you'll notice that those 3 probabilities add up to 1. And that happens as well if I took ham first and beef first. So this idea of things adding up to 1 really encapsulates this problem, and you can use that as a checking mechanism. So for example, if I'd made a mistake and put 1/8 for my last beef option, it wouldn't add up to 1. I'll spot the mistake, correct it. We're also going to use that idea when we get over to here. The probability of egg is 2/72 and egg ham is 8/72, etc, etc. If I add up all of those probabilities, I'll end up with 72/72, otherwise known as 1. So again, this idea of things adding up to 1 is all the way through this problem, and you use it as a check. So the question says, what is the probability that he ends up with at least 1 beef sandwich? So I need to find every possible occurrence that has at least 1 beef. And that's all the ones that I've circled there. Once I've got these, I need to add those probabilities together. And it's at this point I'm going to go back to that idea of why I don't simplify. If I'd simplified these probabilities, I would have lots of different probabilities. 1/36, something over 6, something over 12, something over 15, whatever it might be. And actually, if I'm adding together fractions, I want a common denominator. So the nice thing about not simplifying is that I keep that common denominator of 72 all the way through, which makes my next calculation a piece of cake. And the probability he ends up with at least 1 beef sandwich is 42/72. Again, no need to simplify this whatsoever. 5 marks in the bag. Question 23. So this is a circle theorems problem. and I need to write down every single answer or every single angle I put in with a reason. So I'm going to start off by using the fact that I know the angle O to A to C is 26 degrees, and I know this because OAB would be 90, and that's because a radius and a tangent always meet at 90 degrees. Circle theorem fact. Okay, so you need to make sure that you write that. And what I've done there is I've just done the calculation 90 take away 64. Now there's a couple of things I spot. The triangle OAC is isosceles, and that's because it's made from two radii. So OA and OC are both radii of this circle. So I know that angle O to C to A is 26 degrees because it must match angle OAC. Once I know that, I'm going to use the fact that angles in a triangle add up to 180 to work out that the missing angle X is 128. But at no point will I write down an angle without popping down a reason for it. Okay, question 24, nearly there. This one is a pretty nasty question. This graph shows the function y equals f of x. Don't worry yourself too much about what y equals f of x means. It just means it's a bit like algebra for function machines. So this just means that there is something that happens to x that turns it into y, and this is a graph of what happens. And what we need to do is to sketch the graph of y equals 2 fx. Now, what happens when I multiply a function by a number is it creates a stretch, but it's only going to stretch in a certain direction. And you can kind of think your way through this problem. So if I take those 2 points that are lying on the x-axis, at the minute, the y-coordinate for these is 0. So whatever f of x comes out at, it becomes 0. And if I times anything by 2, or if I do 0 times 2, it's still 0. So those 2 points are actually going to stay in exactly the same place. The next point I'm going to look at is the kind of very minimum point of this curve at 1 minus 1. So at the minute, this comes out at minus 1. Whatever f of x did, y came out to be minus 1. And so f of x happens, whatever that does, and I know I get minus 1. I double it, which would become minus 2. So what that does is that puts that point down there. And hopefully you can see this idea of it stretching out now. It's going to look like a longer graph than we originally had. The next points I'm going to look at, and notice how I'm only looking at certain points here to help me out, is I'm going to look at the 2 points at negative 1, 3 and 3, 3. So whatever happened to create these y values of 3 is now doubled. So these two values are going to end up on 6. And once I've got these coordinates in, I can sketch my curve in, drop it all the way around, nice smooth curve, and job done. Okay, so that's the end of your maths warm-up. Hopefully you found that really useful. Try and take on board some of the things that we've said. Just to recap, things to look out for in terms of exam technique. Read the question very, very carefully. It's very easy to make a mistake when you're in a high pressure environment of an exam, and if you just skim read through something, it's very easy to miss something. Try and figure out what the topic is. Be smart about this as well. Look at the question number. That's a huge clue as to things. If you get a table and a chart and it's wanting you to draw some kind of chart and it's question 3 in your exam, that's not going to be a histogram or cumulative frequency graph, so don't do those techniques. Make sure you've actually answered the question. Again, this goes back to those big, long, wordy questions where it might say, does Mr. Pierce have enough lawn feed to cover his garden? You need to tell me yes or no. You can do fabulous working out and pick up 4 of these 5 marks, but make sure you have answered the question they have asked. After you've finished, check your work carefully. I would use all 1 hour 45 minutes on this exam. I would have no downtime whatsoever. I would be working really hard on it, taking my time, pacing myself as well, and give myself a little bit of time at the end to check through, and I would use that carefully. Don't leave any questions blank. Just thinking about a question and writing a few bits down sometimes unlocks this thing for you. There's lots of students I teach who will look at a question, leave it blank, sir, I cannot do it. And all it takes is a tiny little nudge, and sometimes I'll just write something on their paper and then the penny drops and it's, yeah, of course, I know what I'm doing now. You've got to be able to try and do that for yourselves in this exam. Number 6, show all of your working out. Again, this kind of applies more to the calculator paper, but make sure you are showing me every single calculation that has gone on in your head. If you're getting something right, I don't want you dropping any method marks for it. And the last thing from me to say is to wish you good luck, but also to remind you that at this point in the game, shouldn't be about luck. You should have prepared very, very carefully, worked really, really hard. You'll go into this exam, and I'm sure you will come out of it with exactly what you deserve. Okay, so I wish you well is probably a better way of saying this. All right, thanks from me. Bye-bye.